and the result of the modulo is 1. How do we do it? If we take 15 modulo 3 and start subtracting 3 from 15, in the end we'll get 0. And that 0 means that 15 is divisible by 3. So, for instance, if we perform the operation of 6 modulo 2, we will get a remainder of 0. Then if we do 5 modulo 2, we will get 1. And finally, if we do 4 modulo 2, we will get 0 once again. If we calculate the result of 3 modulo 2, the remainder we obtain is exactly 1. If any number modulo 2 is equal to 0 with no remainder, it means that specific number is perfectly divisible by 2. In other words, even. If we take any number and do modulo 3 and get 0, it means it's divisible by 3. Here's an interesting example, which should also be understood in the same way. What if we do the following? 9 modulo 100, so from 9, we try to subtract 100 as many times as possible. You can't subtract 100 even once, so the result is immediately 9. It's worth remembering that if the modulo is smaller than the number, the result is that smaller number, but that's because you can't subtract 100 from 9 even once. So now let's try to do our task. We've been given a number. If that number modulo, this is how you do it in Python, with the %, modulo 2 gives 0, then we already know that the number is even. And then if that number modulo 3 also gives 0, then we know that this number is clearly even, which essentially means it is perfectly divisible by 2, and furthermore it is also divisible by 3. Let's run it. 15, there's no result because it's not even. 30, it's even and divisible by 3. This task on the list is also meant to show you that programs can be written more simply, provided we know a bit of math. Computer science is basically math, just on a computer. Yes, you could put it that way in short. And this program can be written more simply, because if we're checking whether a number is divisible by 2 and whether it's divisible by 3, then instead we can just check right away and write the program more concisely. Check if the number is divisible by 6. It will be the same thing. Let's run it. 30 is. Let's run it. 15 is not. That was the next task. The next one is, write a program that will display the sum of two given numbers if both are odd. Well, if we know modulo, then this program is easy. There will be the first number, and there will be the second number. Go ahead and input the first number, then enter the second number. And if this specific number is odd, that is to say the first number is odd, meaning the result of modulo 2 gives 1, then we will proceed to check if the second number likewise happens to be an odd integer. Number 2, modulo 2 gives 1. Then we are supposed to calculate and display the total sum of these values. So we print number 1 added to the value of number 2. We execute the program with 1 and 1, and as expected, the resulting sum is exactly 2. We run it with 1, 2, it didn't print anything because the second one was even. We run it with 2, 1, it didn't print anything because the second one was even. We run it with 3, 3, and the result is 6. Next task. In this next task, you are supposed to recall a bit about logic, meaning what ORs, ANDs, NOTs, etc. are. Write a program that asks for an integer x. So let's start with that. We need to ask for an integer x, so x equals the integer from what the user entered, so enter the number x. And now we have this. If the perimeter of a square next to x, so we have some perimeter of a square, let's say the perimeter equals 4 times x. If the perimeter of a geometric square with a side length of x units is greater than 25, that is to say, if the total perimeter is indeed greater than 25, then we can conclude that. Or the perimeter is even. And here, for the purposes of this task, even though the instructions say that in the exercises you can't use and, or not, it will probably be easier to explain what this task is about if we use them. If the total perimeter of the square happens to be strictly greater than the value of 25, or if that perimeter value is an even number, which means that the perimeter modulo 2 is exactly equal to 0, then the computer program should proceed to print the word logica to the console. That is to say, it must output the string logica. On the other hand, if neither of those conditions are met, the program should instead print the sentence, "I like pancakes," to the screen. We run our program, we enter a number, for example, 6. Logica, because the perimeter is 4 times 6. We don't have greater, but it will be even. And now look, if you remember the logic exercises, how OR worked in such a way that if we have true or true, the result is always true. Furthermore, if we have a combination of true or false, that also results in true, because one of them has to be true. So for instance, if I were to say that I am currently recording a new video, or perhaps that I am out walking the dog, then in actual fact I am telling the absolute truth, simply because I am definitely doing one of those two specific things at this moment. Similarly, if we have false, alternatively, if the second part is true, then the entire statement remains true. The only specific case where this fails is if we have false or false, meaning I say two untrue things and both are false, then the final outcome will be false. And here, notice that for this to work, either this or that has to be true. If neither of them is true, then it works. I like pancakes. The perimeter will be greater than 25 if 4 times x is greater than 25. So if, let's say, x is 1, then this won't be true. And when will it be true that the perimeter is even? It will be true when this number will be even, and this number, the perimeter, comes from multiplying x by 4. No matter what number we multiply by 4, that number will be even. So this will always be true, no matter what number we provide. And if this is always true, then it doesn't matter whether this is true or not, because the whole expression will be true. It's enough for one of the two to be true. Since this is always true, it will always be true no matter what number we provide. So there's no chance that the program will display it for us. I like pancakes because there will never be a situation where else will execute. So in reality, this task could look like this, and it would work the same way. So if we do a print, the logic, and this won't be there, the program asks for a number and will write logic if the perimeter was even or greater than 25. It will always be even. So we can just do print logic right away, and that's a correct way to solve this task. Next task. Write a program that given two numbers will print which one is the largest. So we have some number a, and we have some number b. And the first thought that comes to mind is to check whether a is greater than b. If so, then we'll write that a is greater. If that is not the case, then the value of b is significantly greater. Now, this is a perfect example of a specific program where the code itself is written correctly, but the actual mistake lies within our own logical thinking. Just take a look at this. If I go ahead and run this program right now and enter that the value of a is 3 and the value of b is 1, then it will clearly tell me that a is the greater number. The program didn't have any errors because nothing appeared in red. But if I run the program and do the opposite, 1, 3, then it will tell me that b is greater, so generally the program works correctly. But if I run it and enter that a is 1 and b is 1, it will tell me that b is greater, which isn't true. So the mistake is, in our thinking, this happens because the program checks whether a is greater than b. If both are the same, it determines that this is false. And if it's false, it will display that b is greater. And to get around this error, you need to write the program a bit differently. So first we should check whether a is the same as b. If so, then write both are the same or neither of them is greater. And otherwise, if they are not the same, only then should you execute the second part of the program. So as you can see, this specific outcome will occur in the event that variable a is different from variable b. And if a is exactly the same as b, then this other result will happen instead. Now, let me go ahead and run the code 1, 1. Both of these are the same. I run it again, 1, 2. In this case, b is greater. I run it one more time, 2, 1. Now we can see that value a is indeed greater. And this is the correct solution to this task. In the next task, we need to do it so that we check which of the three numbers is the largest. We assume right away in this program that the user will enter each number as different. So there will be one more number, C. And now we need to check which of them is the largest. So based on what we have observed so far, we can clearly see that if the value of A happens to be strictly greater than the value of B, and then if B is also greater than C, then it follows that if A is greater than B and A is greater than C, then we can proceed to write the following command in our code: print A is the largest. And next, now we need to write this program here. But to write it correctly, we also need to test it afterwards. Here's what we'll do. We'll take a short break here. You'll try to write this program yourselves, and first I'll explain how to check if it works. So if we have the numbers A, B, and C, and a message that should appear, it should work like this. If, when testing the program, we enter 1, 2, 3, that is A is 1, B is 2, C is 3, then the program should display C, the largest. If we enter 2, 1, 3, then the program should display C as the largest. If we enter 3, 2, 1, then the program should display that A is the largest value among them. For instance, if we were to input 3, 1, 2, the program is expected to display A, the largest. If we input the sequence of numbers 1, then 3, and finally 2, then the program should show the letter B on the screen, the largest. And if we enter the sequence 2, 3, 2, 3, 1, then the program should also display that the value of B is the largest. Pause the video here, try to finish this little program on your own, and then test it with these data. You can copy this down on a piece of paper to have it on the side, or enter these numbers in another tab. If you successfully manage to write this specific computer program, and it consistently gives the correct answer every single time, that truly means the program is fundamentally correct. However, the program should be thoroughly tested on all possible situations and edge cases. So, only if it works perfectly and correctly in these 6 specific cases, can we then consider the program to be written entirely correctly and ready for use. And I assume that some of you managed to write this program. In fact, it only needs 3 if statements to be written correctly. If you have more of these if statements, then it can probably be written more simply, which doesn't mean it doesn't work. In the exercise, we assumed that we don't use AND. Or not, because of course the simplest way to write it was AND B greater than C. And then you could write that A is the largest and repeat that if statement, but we assume that using AND is not allowed in this task, because that's what the task description says. Now, there is one more important thing to cover. We can use the hash symbol, which is also known as the £sign, to create helpful comments in our code, so that the computer will completely ignore this specific line of text, and it won't display any confusing error messages because of it. Okay, we'll leave this here as a cheat sheet. And now, to write such a program, it's hard to come up with, because I suspect you really had to rack your brains about what to check step by step. However, there are ready-made solutions for such programs, and there are quite a few of these basic ready-made solutions. There are about 400 algorithms out there that you can find. This is one of them. There are algorithms for finding the largest or smallest number among a set of numbers. There are ready-made solutions for this, and these ready-made solutions, since programmers work in different programming languages, are usually presented as diagrams. So we can have such a diagram that shows us how to write such a program. This is called a flowchart. And here I have such a diagram specifically for this task. This diagram looks like this. And from this diagram, we know how to write such a program. And look, when we run our program, that is, we've asked for A, B, and C, we should check whether A is greater than B. So we follow the diagram, is A greater than B? And we have 2 possibilities, yes and no. So we have the possibility of yes, and we have the possibility that it's not true, meaning no. And now if yes, meaning this branch, then we need to check whether A is greater than C. So instead of yes, we check whether A is greater than C. And again, we have 2 possibilities. Yes? No. If yes, then we write that A is the largest. A, I'll just write A. If not, then we write that C is the largest. So print C. And now the other side, so yes. If A was not greater than B, then we need to check whether B is greater than C. So if B is greater than C, and again we have two possibilities. Either it will be so, or it won't. If it is, then we write that B is the largest. Print B is the largest. And if it isn't, then we write that C is the largest. Okay, our program is ready. And indeed, that's enough. 3 ifs are enough to write it. Let's move this a bit here for testing, and I'll run it. I'm supposed to enter 1, 2, 3, and it should print which one is the largest. 1, 2, 3, C. I'm supposed to enter 2, 1, 3, and it should print which one is the largest. 2, 1, 3, C. I'm supposed to enter 3, 2, 1, and A should be the largest. 3, 2, 1, A is the largest. I'm supposed to enter 3, 1, 2, and A should be the largest. 3, 1, 2, A. I'm supposed to enter 1, 3, 2, and B should be the largest. 1, 3, 2, B is the largest. In the last possibility, I'm supposed to enter 2, 3, 1, 2, 3, 1, and B should be the largest. You can see that the program works, so such a flowchart really speeds up our work, and we'll know how to write it without any special thinking. It's worth looking for such flowcharts somewhere. They're available either on Wikipedia or elsewhere on the internet. Of course, it would also be good to understand how it works, but definitely such flowcharts speed up our work. And we have the last 3 tasks left. They are very similar to each other, but here you need to understand how the loop works. Let me explain now. If we want to do something 3 times, for example, write alla Makota, then we need to repeat it 3 times. And we have alla Makota. However, if we had to repeat it 500 times, it would take us about an hour before we even start. Copying, pasting, and so on. And loops are used for repeating certain elements without writing them out one after another. And this is how a loop works. To demonstrate this, we can take one such line of code and write it out right here. We start by typing for floor in range, then we specify the numbers from 1 to 10, and finally, we add a colon at the very end to complete the statement. And this line must be indented with a tab so the computer knows to repeat this line. And that's how it works. This line will be repeated from 1 to 9. It's important in Python that this number must always be entered as 1 greater. If we wanted to go up to 10, we'd have to enter 11. And now look, I run it and it repeated 10 times. This is the simplest example. However, in a loop we can use a variable. We enter the variable here instead of the underscore, so we can do for x in range from 1 to 11. And now we can use this x here in the loop. For example, Ayala has the various X-Men comic books that have been published. And now this will work like this. The first time this line is executed, x will have the value 1. The second time this line is executed, x will have the value 2. And so on up to 10. If I run this, I get the following result. Ayla has 1 hamster, Ayla has 2 hamsters, Ayla has 3 hamsters, and so on. Of course, we can add, for example, 10 to this x, and then we'll have Ala has 11 hamsters, 12, 13, and so on. If I enter 1100 here, the program will work in such a way that it will execute this for us one by one. Okay. There are still a few nuances when it comes to this for statement. For example, you can set it to go up to 100, but to skip every 3. Let's turn on this, plus 10. And now take a look. It goes 1, 4, 7, 10, and so on. You can also run this loop in the other direction, that is from 100 to 3, but with a step, for example, -1, and then it will go from the end. There's also an option to do it here. Actually, in these tasks, it won't be necessary, but without that range, if you provide it, the numbers from the parentheses are taken one by one. So first it's 100, then 3, then -1, 100 hamsters, 3 hamsters, -1 hamster. So let's get back to our tasks. Write a program that will print 100 consecutive natural numbers greater than 100. So we start from 101. We will continue all the way up until we reach the value of 202. And as we iterate through this specific sequence, we are going to proceed to print out the current value of our variable x. And we have 100 natural numbers greater than 100. We can also use something like this with print here. By default, print adds a line break after each execution. We can also replace that line break with something else. So then we type end equals, and for example, instead of a line break, we'll use space asterisk space. So if we run it, instead of a line break, there will be a space asterisk space. The next program will add the next 50 natural numbers greater than 50. So starting from 51 up to 102. And now it needs to add these numbers, and here it might be a bit more difficult. Since it needs to add them, it will be calculating a sum. So we'll set that sum at the beginning to be 0. And then we will add what was already there to our sum, plus this x, so the sum will be 0 at the beginning, then a new sum. This will be what it was, IM 0 plus 51. It will come back here, it will fly here. The new sum will be the old sum, i.e. 51 plus 52, and so on until 102. If we print sum, we know that it came out to 3,700 something. We can also do this print sum inside the loop, so each time as it runs, it will show us how much there is already. And now when we run it, we can see here that it was 51, then 103, then 156, and so on. This is the second to last task and the last task. Write a program that multiplies the next 50 natural numbers, so now it should output the result of the product. And the first thought is, of course, instead of adding, we do multiplication. But when we run it, notice that we get only zeros. The reason we have these zeros is that at the beginning, well, we should have named it product actually, so it doesn't get confused, not sum. Product. We end up with 0. Because the new product is the old product times x, that is the old product times 51. But that old product was 0, so everything gets multiplied as 0. If we want to work with products instead of sums, then the product at the beginning should be 1. And now we have the result of this operation. Well, it's a bit large. Loops are a topic that there are also several types of loops. There's the while loop, the for loop. These are the two most popular ones. Loops are a topic that you eventually reach in programming, and you either get past it, and then it's all downhill from there, or you get stuck at this point. Most people, when learning programming, get to loops and sort of stop there. They don't go further into programming, but in reality, that's what programming is about. It's only after you get through loops that programming becomes really fun. And here, it might be worth visiting a certain website, download it from there, the loops PDF. There are some loop exercises prepared for you there. If you have classes with me, we'll definitely practice these exercises together. However, this is the point where, if you understand it and move forward, it's the moment when it's really worth pursuing programming. Thank you for your attention. I hope this video will be helpful for you to start your programming journey, and I tried to record it in such a way that Thank you very much.